Jamb 2026 candidate, of course, I'm back here to give you what is needed for you to score high your Jamb UTME 2026, following the syllabus bit by bit. You know how my lecture always is. Please get your pen and your notebook to jot down anything you pick up in this lecture. And I want to see you score your 300 plus in Jamb UTME. And do not forget to enable full screen view in your device to enjoy the maximum viewers experience. If the video is appearing blurry, tap on the YouTube settings located at this place. I'm hovering my mouse to select a higher screen resolution, at least 720p. Newton's law of gravitation. What does this law state? The law states that every two bodies attract each other with a force proportional to the product of their masses and inversely proportional to their square root of their distance apart. So the force of attraction between two masses, according to the law, Newton's law of gravitation, the force of attraction between two masses is directly proportional towards the product of their masses and inversely proportional to the square of their distance apart. The formula is a square root, but let's look at what we have, because here we have area. The expression of this law is the force of attraction, which is F, okay? The force of attraction, that's what kind of force are we talking about? Gravitational force, that's why you have G here. F stands for force, G stands for gravity. And we are talking about the mass 1 and the mass 2. Remember, the law states between two masses or between two bodies. Two bodies, mass 1, mass 2. Over is directly proportional towards the product of their masses. That's what we have here, okay? So this force here is directly proportional to the product of these masses. The same force of attraction is inversely, that's why you have over slash arrow square. The square of their distance apart. Arrow stands for area. Ensure you are jotting that in your notes. And take this G, which is the gravitational force, 6.67 times 10 to the power minus 11. This is the constant, okay, which is Newton square per kilogram square. This is it, according to the Newton's law of gravitation. And what is the application of this explanation? That's what Jamb wants from you. Jamb wants that from you. What's the application of this explanation? So what is the application of this Newton's law of gravitation? The application is, it explains planetary motion, it explains satellite orbits and tides. Gravitational potential. What do you understand by the word gravitational potential? Work done per unit mass in bringing a body from infinity to a point in the field. The work done per unit mass bringing a body from infinity to a point in the field. What is infinity? The point of limitless count. Okay, that's infinity. So bringing a body from the point of limitless count to the point in the field. That is gravitational potential. Is the ability for a unit mass of a substance to move from infinity to a point in the gravitational field. As simple as that, ABCD. And the expression is V is equal to minus this one, gravitational force of attraction, G, the mass, M is mass over the area, which is arrow. This area, arrow, stands for the points on the field, okay? The M stands for mass, while this capital letter G stands for the gravitational force of attraction. Remember to always put the negative. So if you are asked to calculate gravitational potential in a physics question, this is the formula you are going to apply, which is gravitational potential V is equal to minus Gm over R. Okay, so gravitational potential energy, they can also tell you to calculate gravitational potential energy, okay, which is U is equal to minus Gm M, that's first mass, second mass over R. Remember, when you are calculating gravitational potential or gravitational potential energy, it comes in negative. All right, conservative and non-conservative field. Jamb says we should look at this. So what is conservative field? We are trying to know the difference between both. Conservative field is the work done independent of the path. The work done independent of the path. That is not dependent on the path, but is the work done. But it depends only on initial and final position. So conservative field depends only on the initial and the final position. That's the key word you have to bear in mind. Conservative field depends only on initial and final positions. For example, gravitational field, electrostatic field, and so on and so forth. So both of this field here depends only on the initial and the final position, and it's independent of the path, okay? It's independent of the path. While the second one we have here is the non-conservative field. Work done depends on path taken. The work done depends on path taken. That's when we say conservative field, we mean those fields of force that does not require contact, okay? It's only dependent on the initial and the final position. That's what matters. But the non-conservative field are the field that requires friction, okay? The first field that requires friction, okay? Work done depending on the path taken. It depends on the path taken, but the conservative does not depend on the path taken. So I want you to picture the differences between them. So frictional force is an example, okay? Contact is needed. It depends on the path to which it moves on or to which it glides on determines the work done, okay? It determines the work done. Therefore, contact is highly needed. Acceleration due to gravity, small letter G. Remember the bigger one is gravitational force, but this one, acceleration due to gravity, is small letter G. Okay, take note of the color codings. What is the expression of acceleration due to gravity? It's expressed as G is equal to gravitational force, M, which is the mass of the body, over R square, which is what? The radius of the earth. This capital letter R square is the radius of the earth, or the area of the earth. So acceleration due to gravity, G is equal to Gm over R square. As easy as ABCD, Shikina. On Earth's surface, gravity or acceleration due to gravity is 9.8 meter per second square. This is very common. Almost everybody knows this. Okay, so variation of the force of gravity on the Earth's surface. Okay, gravity varies due to attitude. That's how far you go. What affects gravitational force on the Earth's surface? What really affects it? Okay, the attitude is one, which is how high you are located on Earth. So altitude decreases with height. So the attitude decreases with height. So what we are saying is that gravitational force decreases the higher you go. The higher you go, the lower the gravitational force. So the next that affects gravity on the surface of the Earth is depth. Okay, depth, you know what depth means. Okay, deep. Okay, deep. Gravitational pull decreases inside the Earth. So it decreases inside the Earth. Like as all of us now, day for where we day for the Earth now. Okay, this place will day for the Earth. Gravitational force, they very low. Okay, it decreases inside the Earth. It's low here. So latitude. Okay, what happens? What is the relationship between latitude and gravitational force? Slightly less at equator due to what? Earth's rotation and bulge. Okay, so the latitude is slightly less at the equator due to the Earth's what? Rotation and bulge. Mass and weight. Mass and weight. What is mass? Mass is the quantity of matter contained in a body, and it's a scalar quantity. Okay, mass is constant everywhere. All these are the facts about mass. What Jamb wants you to know. And mass is measured in the SI unit called kilograms. Okay, that's the standard unit of measuring mass. Mass can also be measured with grams, but that's not the standard unit. The standard SI unit for measuring mass is kilograms. Okay, then the next we have here is weight. We have to understand. Jamb wants you to understand the differences or the difference between mass and weight. And weight can be defined as the force due to gravity on a mass. The force due to gravity. So the difference between mass and weight is that mass, gravity is not involved, but weight, you have gravity in the picture. And weight, because you have gravity in the picture of weight, it makes weight a what? A vector quantity. And what is the formula for weight? Because we define weight as the force due to gravity, we are going to have weight is equal to mass times gravity. That gives us weight. And it varies with gravity. Your weight is determined by your level on Earth. Okay, so the higher you go, it affects the weight. Okay, because weight is the mass of an object or a body due to gravity. Okay, so gravity is involved. So gravity has a role to play when it comes to weight. Okay, the unit of weight is what? Is Newton. The unit of weight is Newton. Remember, it's force. The standard SI unit of weight is not kilograms, so it's Newton. But weight can also be measured in kilograms. But the standard unit for measuring weight is Newton. Don't feel that in your Jamb UTME. Escape velocity. Escape velocity. Take note of the color codings. What is escape velocity? In our last lecture, we treated angular velocity. Now we are treating escape velocity. Escape velocity refers to the maximum velocity required for a body to escape the gravitational pull without further propulsion. So the minimum velocity, the smallest velocity required for an object or a body to escape the Earth's gravitational pull, that's escape velocity. Okay, without further propulsion, that's escape velocity. The minimum, the smallest velocity required for a body or a substance to escape that gravitational pull of the Earth without further propulsion from the Earth's gravitational pull, that is escape velocity. As easy as that, chicken. What is the expression of the escape velocity? We have it here as VE. This is the escape velocity, VE. Remember, angular velocity is that W thing that is like nyash, fresh nyash under, very smooth. Okay, but escape velocity is VE. The symbol for escape velocity is VE is equal to root bracket open 2 G, which is what? Force of gravity, M, which is mass, over the radius of the Earth. Okay, this is the first formula depending on what you were given to solve. Okay, remember, this is gravitational pull or gravitational force, capital letter G, but small letter G here is acceleration due to gravity. Okay, it depends on, I always say that it depends on the parameter that you are given in the question. That's what is going to determine the formula that you are going to use for expressions that have two formulas. Okay, so it depends on the parameters you were given to solve. Okay, so the same escape velocity is equal to root 2g, this one is acceleration due to gravity, times what? Times the radius of the Earth. So it depends on what you have to solve. That's what is going to determine the formula for escape velocity that you are going to use. For example, if you are given force of gravity, that shows that is this formula that you are going to use. Okay, V is equal to root 2 times G times M over R, radius of the Earth. But if you are not given mass, neither were you given gravitational force, just know that it's this one that you are going to use. Maybe you were just given, among your parameters, you were just given acceleration due to gravity and the radius of the Earth. So use this one to get your answer, Shikina. All these are easy formulas, easy. Hope you are making notes, hope you are jotting down. Then this escape velocity for Earth is 11.2 kilometer per second. 11.2 what? Kilometer per second. Escape velocity for Earth. Parking orbit and weightlessness. Jamb says we should understand what the concept of these are and spot out the differences between the two. Alright, so what do we understand by the word parking orbit? Parking orbit is a stable orbit where satellite remains fixed relative to the Earth's surface. So it's also called the geostationary orbit. So anytime you hear parking orbit, always remember stationary, not moving in one position. So that place is the stable place where satellites remains fixed. They know they move, they just remain fixed there. Satellites what? Remain fixed there. They don't move relative to what? The surface of the earth. That's it. The fixed point, parking orbit, they park for there. They remain fixed there, they don't move. Let's look at weightlessness. So weightlessness is a condition where no apparent weight is felt. Very easy. So this one is English word now, it's easy to understand. Okay, weightlessness, condition where no apparent weight is what? Is felt. I'm not feeling any weight. Okay, no weight, I'm weightless, I feel weightless. Like when the elevator is bringing you, is descending. Okay, you are in an elevator and the elevator is descending, you are going to feel some form of weightlessness and even lightheadedness. So if you haven't used the elevator before, you are going to be very shocked and surprised. Okay, you might even get nervous and lose your mind while you are in the elevator. Okay, so what is the example of weightlessness? Astronauts in orbit. Yes, remember, the higher you go, you experience more weightlessness. Okay, that's that. Equilibrium of forces. So what is equilibrium of particles? A particle is in equilibrium. When you hear equilibrium, just know that it means balance. Okay, equilibrium means balance. Balance. A particle is in equilibrium when the vector sum of all forces acting on it is equals to 0. That's it. So the particle is in equilibrium, is in the resting position, is balanced when the what? The sum of all the vector forces acting on it, okay? All the forces acting on it is 0. I am at equilibrium like this because no force is acting on me. I'm not moving, I'm balanced. But when force begins to act on me, I become imbalanced. There is disequilibrium. That's it. As easy as that, chicken. And what is the condition? The condition for equilibrium of particle is this. This is the relation whereby the force is equal to 0. Let me say you are at equilibrium. When the force acting on the body is equal to 0, 0 force, that body is balanced. That body is at equilibrium. Still under equilibrium of forces, coplanar forces. What is coplanar forces? Coplanar forces is the forces lying in the same plane. Coplanar. Co what? Planar. So I decided to call it coplanar forces because that's how I love calling it. So it's coplanar forces. Okay, forces acting on the same plane. The same plane. Forces acting on the same plane is known as coplanar forces. That's why I say it's a co. When you say co, it's like relative, two coming together. Co-plane, okay, planar, coplanar forces, okay, forces lying in the same plane. That's coplanar forces. For equilibrium, the relationship is given like this: F is equal to the coplanar forces is equal to 0, okay, and when this is equal to 0, what happens? The system is at equilibrium, okay, and Fy is equal to 0. So we are talking about the planes, okay. This is for the x-axis on the graph, then this is for the y-axis on the graph, or this is for the s-plane and this is for the y-plane. That's it. Two forces lying in the same plane, coplanar force. And you have to know that when the force is 0, the system is at equilibrium. Still under equilibrium of forces, triangle of forces. What does it entail? If three forces acting at a point are in equilibrium, that's their forces are 0, they can be represented in magnitude and direction by the sides of a triangle taken in order. So if three forces, stereo, acting on the body is at equilibrium, they can be represented in magnitude and direction. They can be represented in magnitude and direction. That's a vector. Okay, they can be represented in a vector by the three sides of a triangle taken in order. Remember our vector diagram where we had an angle like this with angle 45 in the middle? That vector diagram where we treated vector. That's this triangle of forces. That's the illustration of this triangle of forces. So the next we have here, still under the equilibrium of force, is polygon of forces. And what is the polygon of forces? What does it entail? It says if several forces act at a point are in equilibrium, that's their balance. Several forces. Remember the triangle forces, three. Tri means three. Triangle, three forces acting on a body. But here for the polygon forces, remember the meaning of poly. Poly means several, more than three, more than three, that's poly. So these more than three forces acting at a point are in equilibrium. They can be what? Represented by the sides of a what? A closed polygon taken in order. So they can be represented by what? The sides of a closed polygon. You know what a polygon is now, okay? A closed polygon taken in order. With what we have understood so far in the Jamb syllabus and what Jamb wants us to know in preparation for Jamb UTME, let's take some Jamb must repeat questions to test the knowledge we've acquired so far. Jamb must repeat questions. Question 31. Two masses of 5 kilograms and 10 kilograms are placed 2 meters apart. Find the gravitational force between them. Take gravity, G, equal to 6.67 times 10 raised to the power minus 11 Newton meters square per kilogram square. What's the answer? Option A, 8.34 times 10 raised to the power minus 11 newtons. Option B, 1.67 times 10 raised to the power minus 10 newtons. Option C, 3.34 times 10 raised to the power 10 newtons. Option D, 6.67 times 10 raised to the power minus 11 newtons. Drop the answer in the comment section. Question 32. The gravitational potential at a point 10 meters from a mass of 2 times 10 raised to the power 3 kilogram is what? Take force of gravity 6.67 times 10 raised to the power minus 11 Newton meter square per kilogram square. Option A, minus 1.33 times 10 raised to the power minus 8. Option B, minus 1.33 times 10 raised to the power 7. Option C, minus 1.33 times 10 raised to the power 9. Option D, minus 1.33 times 10 raised to the power minus 10. All options in joule per kilogram. Drop the answer in the comment section. Question 33. Which statement is correct? A, mass varies with location, weight is constant. B, mass is constant, weight varies with gravity. C, both mass and weight varies with location. D, both mass and weight are constant. Drop the answer in the comment section. Question 34. The escape velocity from Earth's surface is given by A, V equal to root gm over r. B, V equal to root 2 gm over r. C, V equal to root gr. D, V equal to root 2 gr. Drop the answer in the comment section. Question 35. Three coplanar forces acting at a point can be in equilibrium if A, their magnitudes are equal. B, they are represented by the sides of a triangle taken in order. C, they act as right angles to each other. D, their resultant is maximum. What's the answer? Drop the answer in the comment section.